Okay, so we have this equation and we have our range x has to be between 0 and 2 pi. So I'm going to start and solve this. I'm going to convert that using my double angle formula. So that's 2 sine x cos x. I'm going to convert that to 1 over cos x. Okay, now I want to make this all equal to 0 to simplify it into an equation. I'm going to multiply the 2's. And on this side I'm going to multiply, well, I'll do that in the next step. I'm going to multiply this cos x on the top there, so this becomes 4 sine x cos square x equals to 1. Then I'm going to subtract the 1 on this side, so 4 sine x cos square x minus 1 equals 0. Now if I look at this, it's actually impossible to solve this. That's not square rootable, so I can't do difference of squares. There's sine and cos, so I can't really solve it. So I'm going to convert my cos square to 1 minus sine square. And then I'm going to multiply this into the bracket. So 4 sine x minus 4 sine cube x minus 1 equals to 0. And then I'm just going to rearrange it to put this term first. So negative 4 sine cube x plus 4 sine x minus 1 equals 0. I'm going to rewrite this as a polynomial equation, so I'm going to replace sine x with y's. So minus 4y cubed plus 4y minus 1 equals to 0. At this point here, you're going to try and solve this using synthetic division, but it's actually not possible to do. You won't get the factors, it's too hard, and basically if you reach a point here where you reached a equation, a cubic equation or higher, there's probably a different way to solve the problem. I tried putting this in an online calculator, I factored it, the solutions are extremely difficult, not possible to do it in a test, and then I solved the question using those solutions. But there has to be a different way to solve this if this is not the way. And again, typically you try to solve these equations using algebra. If this was a quadratic equation, you could use the quadratic formula, find the solutions, and easily find the number of points of intersection and what they were. Okay, so since we can't solve it that way, I'm going to rewrite the question. 2 sine 2x equals to sec x. And the only other way we can solve this question now is to graph it. And if you look at these two functions, they're actually pretty easy to graph as long as you know the shapes. So let's start graphing it between 0 and 2 pi. Okay, so first I'm going to start by just doing my 4 key points: pi over 2, pi, 3 pi over 2, and 2 pi. Now I'm going to start by drawing the first 2 sine 2x. That's a bit of an easier one. So the first thing I'll do is I'll calculate my period. My period is 2 pi over k, which is 2. So my period is just pi of one wave. So basically I know my amplitude is 2 as well. So 2, negative 2, and that's my first point, my second point, third, fourth, fifth. So that's one wave. And then again I have one point here, another point there, another point there, another point there. So another wave in another pi. So that right there is 2 sine 2x, which again you should know how to plot on a graph. The next one is sec x. So sec x basically has asymptotes at pi over 2 and 3 pi over 2. And basically it's the opposite of a cos wave. So a sec x wave starts at 1, the same as a cos wave, but it goes in the opposite direction. It goes towards the asymptotes. So it basically looks like that. Then it continues from down here. It reaches a maximum height of 1 at pi. So pi is right there. It's gonna go something like that and then go back down towards the asymptote. I haven't drawn that with the perfect scale, so this might be slightly off, but you get the idea. And then it continues back from up here and it comes back down, and then again you have a minimum at 2 pi. So basically, if we look at this, we know that there's 2 points of intersection there and there's 2 points of intersection here as well. So we have a total of 4 points of intersection. And in this question, we can only find the number of points of intersection. We can't find the actual points because, like I said, this equation is too hard to factor mentally. You need to use online calculators. But if this equation was slightly easier to factor and you could factor and solve it, you could find the exact points of intersection as well without using an online calculator.